So a mega event always starts with a star speaker. So let me welcome Mr. Michael Bolton here. He's a legend by himself. He is a consultant and trainer who specialized in rapid software testing. He basically helps people and organizations find product problems and also solve it through testing. And also he solves the testing hurdles with his extensive knowledge and experience. Sir, we welcome you as our first keynote speaker for the event. We are very glad to have you with us. Hi, Michael. Can you hear us?
Yes, I can hear you. I'm looking at this and just what a dog's breakfast of an application Microsoft Teams is. My goodness.
Yeah, we need to write a review, Michael, for that. Definitely.
I log in right away. Your microphone has been unmuted. Please click to activate your microphone. I'm pretty sure I saw just now. And this sort of thing that drives me bananas. What drives me bananas in my daily life. Oh, look at this. And here's a copy of, look at that. Is that going to work now? Okay, I'm presenting. What do you see? Do you see a title slide?
Yes.
Yes, we see that.
Oh, no! Microsoft Teams has recovered. And what did they say, of course? Oh, there's been a glitch. Please try again later. The state of testing and quality are in a parlous state. So let me get into some of the reasons why. I think I can tell us why, and maybe we can think of some ways in which we might get out of this trouble. Let's start with this. If we're a business developing a software, what does the business want? If we're in a business, well, the business wants a product of high value because that's how it's going to keep customers happy, and that's how it's going to make some money because the customers will give it money. And in order to do that, the business envisions an idea of success and sets us to building the product, us as the development team, not as testers. Testers don't build the product. We help the people who do, but we don't build the product. All right, next. We build the product, and that's how the business gets something that it can sell. Yay. And in order to do that, the developers go to work. They start building the product. They start focusing on the nitty-gritty, the little bits and pieces, the details of the product. And now while all that's going on, the business wants to keep the cost of development low. That's a big deal. They don't want to spend any more money than they have to. I'm just going to bring this clock up so I know how much time I have left. I hope you can grant me a couple extra minutes. Anyway. This is how the business gets something it can sell. It wants to keep the cost of development low as it's doing that, because that helps make the business sustainable. The business keeps going if it gets a high value product and the cost of development is sufficiently low. Now, there's always risk. There's always risk, and it's a good idea as we're envisioning success. It's also a good idea for us to anticipate failure. So, as we do that, we study what we built to find out if the business really got what the business really wanted. All right, well, all this looks wonderful. What could possibly go wrong? Well, it seems to me that there are 4 prominent ways in which this could go wrong, each one of them reflecting each one of those little corners. As we are at the intersection of the high value of the product and building it, we might not be clear on what the customers would want the product to do, what they want from it, and correspondingly, we might not be clear on how to build it. As we're building the product, trying to keep the cost of development low, we may be committing easy to find avoidable errors as we try to build a product. Committing there is a bit of a pun, right? We may be making mistakes, but we also might be committing them to the repository. All right, as we keep the cost of development low, we're anticipating failure. We know we want to study what we built. Well, it might be hard to know what to build because we haven't been sufficiently clear on this and this. And it might also be hard to identify deep problems in the product, problems that are hidden or rare or subtle. There may be serious problems in the product that can escape even a highly disciplined development process. So, what can we do about that? I think we can do 4 kinds of testing, 4 flavors of testing. And one of the reasons that there's controversy in the world of testing is that various tribes, various groups, various societies in testing have different notions of what they want to focus on, and they have different notions of the job that has to get done. So this, if we understand each other a little better, maybe there's a way to achieve peace in our time. So let's see what we can do. We might not be clear on what the customers would want the product to do and how to build it. In that case, we want testing that focuses on our intentions, testing that focused on the design, testing that is focused on the intentions for the product, review that can help us to discover what the customer actually wants from the product, and how to build it. When we get into the builder's space, into the builder's mindset, we might be committing those easy to find and avoidable errors. So we start to do testing that's focused on the discipline of programming. And that includes things like review of the code, pair programming, shallow testing, and I'll get to that in a minute. It sounds like an insult, but it's not. Shallow testing and low-level output checking, probing the code as we're building it, that can help us to confirm that what we've just done is reasonably close to our intentions, what we intended to do. As we are contemplating how we might be sure of what we're building and how we might evade those problems that escape a disciplined development process, we can focus on preparation, mostly practical testability. The idea of testability, organizing the product and the project and systems and ourselves as testers in order to make testing work easier and faster so that we can test efficiently and quickly and thoroughly. When we move to the process of studying the product to see if we've got a product of high value or if there are things in it that threaten the value, as we move to that, we are moving into what we would call the realization frame. The realization frame is one in which we do deep testing. That is, gaining experience with the product, interacting with it, studying it, learning about it, developing models of it, covering it with testing to help us discover rare, hidden, intermittent, emergent problems, problems that can get past even a highly disciplined development process, because sometimes the problems aren't in the parts. Sometimes the problems are in how the parts are put together, and sometimes the parts are based on realization that we've got problems in the product that we didn't anticipate, that we didn't realize were going to happen. Now, there's another pun at work here, and that is that realization also refers to realizing our goal, achieving something, having built it. So having realized our goal, we want to realize quickly if there are problems in the product that threaten its value. Okay, well, this sort of stuff has always been true in terms of the fact that you can look at any development model, any development project, and you'll see these patterns repeating, I think. You'll see this a cycle of focusing on the high value of the product, discovering something worth building. And then we build something. And as we try to keep the cost of development low, we could say that we attempt to build it virtuously. We build it well. We build it smoothly. We build it in the way we like to build it so that we can get our work done nicely. And then we study what we built so that we can discover something worth building again or something worth fixing if we didn't get it right. So in the traditional development cycle, it's fairly straightforward. We discover something worth building and we build some of it. Over a period of several months, we build almost all of it. And we work on building and building and building and building and building. And as we're building it virtuously. Now, because it's going to take a long time to build a product, and because there's a risk that we're going to get things wrong, we want to try to get it right the first time. And one of the ways that people have done over the years is to try to do that by making development slow and ponderous and expensive by getting the requirements exactly so, and then getting the coding exactly so, and making development itself kind of slow. And of course, in that frame, one of the things that we do is we kind of make development and testing slow too. We make development testing slow as well. We do that by making testing ponderous, focusing on documents and artifacts. But here's the thing, because we spent so long building the product without actually testing it, look at all the bugs. We discover the bugs at the end of the development process, at the very time when we're vulnerable. So we discovered something worth fixing at that point. And after the first long loop, we've got a bunch of very short panicky loops while we try to fix the problems that we were unaware of as we were building the product because we weren't testing it all along. That's a traditional form of software development. And then came Agile. Hurrah! There's a manifesto for Agile software development. When you go to the Agile site, agilemanifesto.org, you'll see this stuff. We're uncovering better ways of developing software by doing it and helping others to do it. Uncovering is right. They were recovering, really, ways that software development had been done 30, 40 years earlier. This discovery, this so-called uncovery, was made in 2000, but it harkened back to the way software was being developed in the 50s and the 60s. In this work, we've come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over negotiated contracts, and responding to change over following a plan. That is, while there's value in the things on the right over here, we value the items on the left more. We'll come back to that. So there you go. There's the manifesto for Agile software development. Now, there are other things associated with that too, though. There were principles that informed Agile software development. So let's see what those would look like. In the Agile software development landscape, when we build the product, we don't do it all at once because the principles say that our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And we welcome changing requirements even late in development. Now, if that's right, we're not going to be able to get it right the first time because the first time, in a way, is always changing. We're always doing something new and different with the product. So to keep the cost of development low, one thing we want to focus on, and we've cherry-picked this from the 12 principles, James and I did when we developed this, this table, this set of quadrants. We cherry-picked this one: continuous attention to technical excellence and good design enhances agility. Continuous attention. So there's a building focus here on this side of the table, and there's a testing focus more or less on this side of the table. So what does that look like? Well, in Agile contexts, individuals and interactions over processes and tools means focusing on the skill sets and the mindsets of the people who are doing the testing. Working software over comprehensive documentation means eliminating wasteful documentation, not eliminating documentation, but the wasteful stuff, and emphasizing investigation and learning. Customer collaboration over contract negotiation means focusing on the project and the needs of the clients and the business as we're testing, and responding to change over following a plan means responding rapidly to the ever-changing mission of testing as the product itself changes. So what does that look like? As we go through the cycle, instead of building some of it, we build almost none of it, and we do inexpensive, shallow testing as we go. Build it virtuously changes from get it right the first time to build it with change in mind, build cleanly and simply, and prepare to make deep testing less expensive as we go by building it cleanly and simply and by doing lots of testing along the way. We study what we built by performing deep testing, but not just on the whole product, on every little piece of the product as we build it, so that we can find problems before they get buried, and so we can fix those problems and then avoid inflicting them on customers. So as we're discovering something worth building, we're discovering things worth fixing as we go. So we do that in lots of short loops to try to keep ourselves from getting ahead of ourselves, overrunning ourselves, to get rapid feedback, and to keep development fast, but also sustainable. Now, I promised I'd tell you what I meant by shallow and deep. Shallow testing is testing that has a chance of finding every easy bug. And what I want to emphasize about that is it's not an insult. Shallow testing is a good thing for two reasons. Number one, shallow testing doesn't slow down the developers. Quick, easy, fast testing of small parts of the product really quickly and really easily help us to make reliable progress without slowing down the programmers. Plus, if we're going to do deep testing, we've got to start with shallow testing. In order to get into deep water, you've got to go through shallow first. So deep testing is testing that maximizes the chance of finding every elusive bug that matters, every bug that might get away from even a disciplined development process. That kind of testing takes time, and it takes effort, and it takes skill, and it takes focus. And it can be really disruptive to development work because developers are focused on getting the product built, envisioning success. It's us as testers who are focused on anticipating failure. So there's different pacing for different kinds of testing that we're doing. When there's risk, we need deep testing to find the deep problems, the problems that we might have missed. Now, what does it mean to do agile development? It means to deliver frequently so that we can efficiently evaluate the product and release it efficiently too. It means to collaborate across roles and to take advantage of all the different skill sets and mindsets that we've got throughout the product. It means to develop craftsmanship. Remember what they were saying about attention, continuous attention to good design and technical excellence. Not being too formal, using heuristic approaches, not trying to follow rules, but trying to follow guidelines and being adaptable to those things. Because formality can be expensive and it's often unnecessary. If it's necessary, we'll do it, but we won't do it if it's not necessary. I am getting a message right now from, oh, look at this. I'm getting captions and subtitles from Teams. Isn't that great? I don't want this. How do I get rid of it? I don't know how to get rid of it, so I'm just going to ignore it. Thank you once again, Teams, for disrupting me. Applying appropriate heuristics. When we're building something new, we're likely to be confused and we're likely to make mistakes. So we should be prepared to try things, and we should be prepared not to succeed with them and to learn from those experiences. We would develop and apply tools in agile development, of course, and we use those tools, among other things, to help us build the product and to help us find errors quickly and to help us find deep problems. We maintain a sustainable pace. If there's too much work for anybody on the team, including testers, the pace is not sustainable. So let's avoid that. And if we need help as testers, then we should ask for it and expect to get it from the rest of the team. All right. So we've got that realization, preparation, intention, and discipline frames. What do they look like in a rapid approach to agile testing? Well, for the intention frame, we discover something worth building. As we do so, we develop the design. That means establishing quality criteria, engaging with lots of different users, specifying the product with examples, not by examples. You can't specify a product by example, but examples can help, especially if they're good, rich ones. We can review reports from the field, explore the trade-offs that we would have to make in order to achieve levels of quality that are desired by various different people. We would refine our user stories as we go. We do all that so that we can build some of it. We can build some of the product. And as we do so, we build it cleanly and simply. Well, what does that mean? It means automating low-level checks. It means doing the kind of testing that would help us to evaluate the product and establish and adhere to a shared coding style. We would investigate and fix bugs as we go. We would review each other's code. We would build and integrate the product frequently so that we could examine it and interact with it and get experience with it and learn from it. And we would be refactoring for maintainability, and the developers would be doing much of this work, an awful lot of this work, I would suggest, because it's work focused on the discipline of programming, as well as focused on finding every easy bug. That's what's happening in here. In the preparation frame, we build with change in mind. So as we do that, we're anticipating failure. As we do it, we foster testability by preparing test infrastructure, by designing for intrinsic testability, putting stuff into the product and looking for it in here so that the product will be easy to observe and maintain and evaluate. We test in parallel with coding, not after coding, but right in parallel with it, not after all the coding's done, along with it. And we provide access to all the levels of the product so that we can look at the product at the very fine, refined degrees and at the very wide open ones too. We try as testers to minimize disruption to the programmers and to the testing process while the product is changing. And we try to remove distractions and obstacles to testing, especially in this frame here. In the realization frame, after we foster testability, we've done that so that we can study what we built. In the realization frame, we experiment with the product, we explore it, we experience it imaginatively and suspiciously, skeptically assessing whether we're done, not trying to show or confirm that we're done, but saying, you know what, we might not be done. Let's find out how we're not done. We model the system in diverse ways. So lots of different models help us find lots of different bugs. We develop rich test data. We focus our testing on suspected risk, and we build our models of suspected risk. We investigate mysteries and discover more mysteries, and we investigate them too. And we can tell compelling stories about bugs, not only in our own product, but in about other people's products. That's what we do as we're building the product so that we can discover something worth building or something worth fixing. All right, so what's the big deal about the dedicated testing role? Why is this important? Because, you know, the developers could do all their own testing, right? Why have dedicated testers? Here's why, I think. When people are focused on developing their intentions, that's a great thing to do, but they're sometimes sweeping the idea of failure away from their minds. They're focused on ideas about the customer that may not be fully baked, and they may not inform the discipline of development as much as we'd like to. It's the testing role in this frame to identify things that could go wrong with our intentions and with our designs, and it's a testing role to ask for testability. In this frame here, as I've already said, this is more oriented towards the discipline of programming. Now, developers like to program, and lots of testers do too. Meanwhile, many programmers, and alas, many testers, think that low-level output checking and integration checks, and even writing programs in order to check the program from end to end, many people think that that's all there is about testing. But there's a big difference between checking the build and testing the product. When it comes to testing, this is it's not insignificant, but this is kind of the easy part. This is the part where we check to make sure that the machinery is working properly, that the gears are turning, that all the teeth are there, that the wheels are spinning right. This is a metaphor that comes to us from our mentor, Harry Collins. There's a big difference between doing that, though, and finding deep bugs that matter to the people who are going to use the product. Now, in the preparation frame, there are very few people on the team who are focused on testability, and testability doesn't get into the product by accident. So, in this frame, the testing role is to advocate for practical testability, organizing our stuff in order to make things work efficiently. Very few developers indeed, and maybe too few testers, have the determination and the skill and the patience to test the product deeply, experientially, getting our eyes on the product and learning about the users by immersing ourselves in the world of the user. That's something that we've got to learn how to do, I think, much better in testing than we're already doing. We need to figure out ways to get into the worlds, the mindset, the skill sets, the forms of life, as a sociologist would say, of our users so that we can find problems that matter to them, and so that we can find problems that may have got past us earlier on in the intention or the discipline or the preparation frame. Maybe there's a problem here, you see. This is what I'm worried about. What I'm worried about is that over the last several years, because of a fascination with programming that's almost inevitable when we're working in a culture of programming, and because of a certain kind of techno-chauvinism, the idea that machines are good and people are inherently bad or slow or error-prone, or they get bored, or they find things to be tedious, I think there's too much focus maybe on this discipline frame, and maybe even too much focus on the intention frame relative to someplace else. And no, I'm not talking about the preparation frame, because there's lots of focus these days on building the product, and there's lots of focus on continuous integration and continuous delivery. Those are all good things. But relative to this, maybe we've got a bit of a vitamin deficiency in the skills of experimenting with the product, of experiencing it as people will and as people do when it comes time to use the product, to find the kind of bugs that would frustrate the user's intentions and desires for what they want to do with the product. Too often, I think, we're focused on our ideas about the product, the builder's ideas about the product, and not enough in testing on the end user's idea of the product. And I'm not just talking about any end user. I'm talking about people who have actual expertise in the disciplines in which the product is going to be used. So instead of using the product just as I would use anything that has buttons and fields to fill in, if I'm going to be using a word processor, I need to invent a lot of roles in which people might use word processing software. People carelessly refer to that stuff as manual testing. One of the ways that we could talk about this, I think, productively, is by talking about experiential testing, interacting with the product in a way that reflects the people use it in its natural context. Testing where, if we watch the tester, what we would see would be indistinguishable in a practical sense from what end users actually do with the product, the way that they get value out of it and the way they might find value to be threatened. I would like to reduce our emphasis on confirming that everything is okay and restore our emphasis on finding problems that actually matter. Using all the usual stuff we've got, like user stories and requirements documents and specifications, but also taking advantage of the tester's range of experiences and the tester's range of feelings and the tester's senses and the tester's emotional reactions to what's going on in the product, and not dismiss them as is so easy to do when all we've got is machines running automated checking. Trying to apply in that fourth frame, in a discipline frame, a minimum of mediation, even though we might be using powerful tools to probe and analyze the product in that frame, let's not forget that if people are going to be using our product, we've got to get the idea under our belts that people are going to be using our product. In other words, when we're testing, we've got to remember to use the damned product and to interact with it. Now, I have a little bit more to say, but let me end with this.
Yeah, thank you, Michael. I was just about to give you a time check. We have a lot of questions, actually. Let me just share my screen here. But in interest of time, probably we will take all the questions during the panel discussion. Is that okay with you?
That'd be fine with me. I want to end with this little point here, that this set of questions applies to each of those four frames that I showed you. Four questions that we can ask at any point during development, focused on anything. Do we know how this thing should work? Are we building what we think we're building? What must we do to be ready to test efficiently? Do we know about every important bug? Now, here's the mind twist that I want to put on you, which is the way I'll wrap this up. We can apply these four questions to any part of the development process and of the testing process, because although we talk of testing in terms of timelines, development is not a line. It's not even loopy. Development is a fractal. So we can apply these frames, these ideas of framing, to not only the product, not only the project, but to our testing as well. Those four questions. We know how this thing should work? Are we building what we think we're building? What must we do to be ready to test efficiently? Do we know about every important bug? We can apply that to our ideas about discipline. We can apply that to our ideas about preparation. We can apply that to our ideas about realization. And we can also apply it to our ideas about our ideas in there. So testing is a fractal. Testing is something that not only we're going to train onto the product, but onto the project and onto our testing work so that we're evaluating our own testing and doing the best testing work we possibly can. I'm done for now. Thank you.
That's fantastic, Michael. I really like the way you combined all the technical and the business risks and gave this talk. There are a lot of questions that have flooded in for us, but then again, because of the time crunch, we will definitely take it in the panel discussions, or we will share it with you and get them answered for sure. Quickly, thank you so much, Michael, for being with us. So we are very glad to share this stage with you.
Thank you. And I promise, by the way, that if you give me a venue, that I will answer every one of those questions in writing after I'm done, sometime before the conference ends, I would hope.
Yeah, thank you so much. I think everybody would love to get them answered.